students, this video is to show you more word problems where we use trigonometry, so that's sine, cosine, and tangent, and inverse sine, cosine, and tangent. So these word problems we will solve for side lengths and angles. Okay, example 1. Find the angle of elevation. So what does that mean? Angle of elevation means the angle going up. And actually on the diagram we can see that that angle is marked with X. Find the angle of elevation if you are standing 400 feet away. So this is where we are, and it's 400 feet away, and the building is 850 feet tall. So that's the height. We want to outline our right triangle, and let's draw it on the side here where we have the right angle. X degrees is our angle, 850 is our height, and 400. So if you remember, now that we have a right triangle, here's our reference angle. We label our sides all the way across. Opposite. The leg that's next to, adjacent. Let's use SOHCAHTOA and see which trig function should we use. We have A, here's an A and here's an A, and we have O. Here's an O and here's an O. So we'll use TOA because that has A and O. Remember, this stands for tangent of our angle, which is X, equals O first divided by adjacent. We want to get X alone, so we're going to apply inverse tangent on both sides. Remember, tangent and inverse tangent undo each other, and what we do to one side, we have to do to the other. We're left with just X on the left because they cancel, and we have inverse tangent of 850 divided by 400. Here, our variable is alone, so we're going to use our calculator. So we'll go to Desmos, and we click on the function button to get inverse tangent. We go back to main, and we had 850 divided by 400. We're in degrees, so 64.79. So X equals 64.79 degrees. That little symbol means degrees, and that is our answer. That's the angle going up, the angle of elevation. Let's try another example. Here, there's no diagram, so we need to draw it. I encourage you to pause and try to draw this on your own, and then check your work with me. You are in a hot air balloon. If you don't know what that is, it looks like this. It looks like a balloon, and it has a basket for people to stand in. That is 600 feet above the ground. So that's telling you your height. This is 600 feet. And we measure height at a 90-degree angle. If the angle from your line of sight, so it's talking about from your eyes to your friend, is 20 degrees, that's actually, your line of sight angle is actually here, because let's think about a person's eyes. The line of sight goes like this. So that's the 20 degrees. But we can find this angle. Let's call it X, because we know that this whole angle is going to be 90 degrees. So 90 degrees should equal 20 plus our X. So we find out that when we subtract 20 on both sides, 70 equals X. So this angle is 70 degrees. Okay, so that was the angle from our line of sight. How far is he, the other person, from the point on the ground that's here below the hot air balloon? So the question is asking us to find this distance. Let's do the same thing we did last time, where we trace out our triangle, and we'll redraw it. There we go. Right angle, 600, 70 degrees, and Y. So this time we want to find a side length. We still label our sides all the way across. O, next to A, we have A, we have O. Let's think so, ka, toa. Which one has both? Toa. So it'll be tangent of opposite first. Tangent of our angle, 70 degrees, equals opposite first, Y, divided by adjacent, 600. We want to get the variable alone, so we will multiply by the bottom number, which is 600. That cancels on the right to just Y. And now we need to use our calculator because the variable is alone. So we'll go to Desmos, clear this, and we'll do 600 times tangent of 70. Did I have that right? Yep. 600 times tangent, so 1648.48. 1648.48 equals Y. So the friend is pretty far away. Let's do 2 more examples. A large balloon is tied to the ground and flying in the wind. So here's my large balloon. If it's windy, the string is going to be at an angle. And it's tied to the ground. The balloon string is 80 meters long. So where we drew the string, we know it's 80 meters. The angle the string makes with the ground, so string and ground, this angle is 40 degrees. How high is the balloon above the ground? So we want to know, what is that height? Let's go yellow. Let's outline our right triangle and then draw it separately. X, 80, 40 degrees. Our first step is labeling sides all the way across. O, across from the 90-degree angle, that's our hypotenuse. So if we have O and H, we're going to use SO, which means we use sine of our angle equals opposite first, x divided by hypotenuse. Just like we did in the last problem, we're going to multiply by our bottom number on both sides. That cancels. And now our variable is alone, so it's time to use our calculator. We'll type in 80 times sine of 40. 80 times sine of 40, 51.42. 51.42 equals x. That's how tall the balloon is above the ground. Let's do one more problem as practice. Why don't you try pausing the video, drawing the diagram, and solving? Check your work with me. All right, so you've tried it on your own and now you're checking it. A ladder that is 30 feet long needs to reach the top of a building. So let's draw. What does that look like? Here's the ground. Here's our building. And a ladder looks like this. It has steps for you to climb. It's like stairs. Let's go back and reread. The ladder is 30 feet long. So we know this length is 30 feet. The building is 27 feet tall. So this is 27 feet. And buildings are built at a 90-degree angle to the ground so that they stand up straight. What angle will the ladder make? Ladder make with the ground. So here's the ladder, here's the ground. The angle is what we want to find. Let's identify our right triangle. Redraw it. We know this is 27 and this is 30 and this is x. We will label our sides all the way across, opposite, across from the 90-degree angle, hypotenuse, O and H. That means we should use sine, S-O-H. So sine of x, our angle, equals O, 27, divided by H, 30. We want to get x alone, so to undo sine, we will use inverse sine on both sides. We do this because sine and inverse sine cancel. We just have x. And on the right, we have inverse sine of 27 divided by 30. Since our variable is alone, we use our calculator. So go to the Desmos calculator. We're going to click on the function button, the inverse sine, back to main, and then 27 divided by 30. 64.15. So x equals 64.15. So that is the angle that the ladder makes with the ground. I hope this video was helpful, and if you're still confused or having trouble, please come for office hours or send me an email on Schoology. Have a great rest of your day.